Good morning, guys. In the last session, we completed our discussion related to config map and secret. Config map and secret are used to supply environment specific properties to the container at the time of container creation. Instead of hard coding the environment properties in the application, we will decouple our application from the environment properties so that our application will be portable to deploy in any environment. After that, we discussed the summary, what we have learned in the Kubernetes so far, right? And we discussed about what is stateful set in the Kubernetes, what is stateful application, and what is stateless application. So the application which is remembering the data is called as stateful application. The application which is not remembering the data, that is called as stateless application. Here, to deploy stateless applications, we will go for deployment. And to deploy stateful applications, we will go for stateful set. Right. What is stateful set? Stateful set is the Kubernetes components. It will create the pods with the sticky identity. First, primary pod will be created with the sticky identity as 0. After the primary pod is created, by copying the data from the primary pod, the pod replicas will be created. Primary pod will be used for write operations. Remaining pods will be used for read operations in the database. And when we are going for the stateful set, the service we are going to create as a headless service. That means we don't give any IP address. So to specify the service as a headless service, we'll specify cluster IP as none. In the last class, we have seen practically how the pods are creating with the kind as deployment, and how the pods are creating with the kind as stateful set. Good. So here, the difference between the deployment and stateful set, deployment will create the pods with random ID, and deployment will scale down the pods in the random order. Deployment pods are stateless pods. Stateful set will create the pods with the sticky identity, and stateful set will scale down the pods in the reverse order. So stateful set pods are stateful. So in the real time, when we are deploying the application, we will go for deployment concept. I mean, the application, backend application, front-end application, whatever we are deploying, for that we will go for deployment concept. For database deployment, we will use stateful set. For the stateful set YML file, I have uploaded to our GitHub repository. Perfect. And another component available in the Kubernetes, so that is daemon set. After the stateful set, we are trying to understand another concept, which is daemon set. Daemon set is also one of the Kubernetes resource. So as of now, we have seen how to work with replication controller, how to work with replica set, deployment, and stateful set. Replication controller, replica set, deployment, and stateful set. Similarly, there is a concept called daemon set concept is available. So what is daemon set in the Kubernetes? Daemon set. Guys, here, whenever we are deploying our application on the Kubernetes cluster, we are giving the pod replicas 2 or 3 or 4. Now, when I give 2 or 3 or 4 pod replicas, here, do we have any control on the which node our pods should be created? Do we have any control on which nodes our pods should be created? Guys, do we have any control on which node our pods should be created? For example, here I'm giving 4 replicas. There are 2 nodes available. In which node my pods will be created? I don't have any control on that. That will be decided by control plane. Here, when you go for Kubernetes resource daemon set, when you go for the daemon set will deploy one pod in the each worker node. If you want to create one pod in the each worker node, then we will go for daemon set concept. So what is daemon set? It is a Kubernetes resource to create the pods. It is Kubernetes resource to create pods. Daemon set will create one pod in each worker node. Daemon set will create one pod in each worker node. So if you want to create a pod in the each worker node, then only we are going for daemon set. Sir, where we are going to use this daemon set in the real time? So the daemon set will be used for logs monitoring. The daemon set will be used for the logs monitoring. Got it? So what is the meaning of logs monitoring? Whenever my application is running, the pods will be available in multiple worker nodes. My application pods will be available in the multiple worker nodes. So in the worker node 1, logs will be generated. In the worker node 2 also, logs will be generated. In the worker node 3 also, logs will be generated. You see here, my microservice 1, microservice 2, microservice 3, multiple microservices will be available. All my microservices will be running on the different worker nodes. Now you see my cluster architecture. So my EKS cluster is available. I have control plane and I have worker node 1, I have worker node 2. Similarly, I can have worker node 3 also. Now from the worker node 1, in the worker node 1, my pod is running. In the worker node 2, my pod is running. In the worker node 3, my pod is running. In the worker node 1, assume that there are multiple pods running here. And here there are multiple pods running here. Now from each worker node, I want to collect logs. So here, this is my log file and this is my log file. I want to collect the logs from each worker node. In order to do that, we are going to create one pod in the each worker node. To create one pod in the each worker node, we will go for daemon set. Daemon set is a Kubernetes resource to create the pods. Daemon set will create one pod in the each worker node. Generally, to deploy the database or to deploy the application, we are not going to use the daemon set. Now let us see what officially Kubernetes is telling about the daemon set. Daemon set Kubernetes. Now go to official website of this daemon set. Daemon set ensures that all nodes run a copy of the pod. As nodes are added to the cluster, pods are added to them. As nodes are removed from the cluster, those pods are garbage collected. Okay, deleting a daemon set will clean up the pods it created. So what is the meaning of daemon set? Daemon set is used to create a copy of the pod in the each worker node. What are some typical use cases to go for the daemon set? Now, running a cluster storage daemon on the every node. So in every node, I want to run some storage pod. So each worker node should have a copy of the pod. And the second one, running logs collection daemon on every node. So in my worker nodes, my application pods are running. I want to collect the data from each worker node. For that, I will create one pod on the each worker node, log collector pod. As you see in the diagram, Logstash is available. Logstash is one software that is used to collect the logs from the nodes, right? So Logstash, I will deploy as a daemon set. So what is the advantage if I deploy Logstash as a daemon set? Each node will have a pod to collect the data. And the third one, running a node monitoring daemon on every node. Now, I want to monitor each worker node available in my cluster. What is the health of the cluster? What is the health of the cluster? How the nodes are running on the cluster? I want to monitor health of each worker node. To run the health of each worker node, in each worker node, one pod should be available. So if you have a requirement like this, to run a storage on each worker node, to collect the logs from the each worker node, to monitor each worker node, then you need to deploy your pods as daemon set. Okay, so what is a daemon set? Daemon set ensures that all nodes run a copy of a pod. As nodes are added to the cluster, that means if your node is increased, suppose 2 nodes are available, you need one more node. So if you are adding one more node, then one more pod will be created. Suppose if you delete the node, then pod will be deleted. So like this, daemon set is one resource in the Kubernetes. Daemon set will create one pod in each worker node. When we add a node to the cluster, then pod will be added. Then pod will be created. If we remove node from cluster, then pod will be deleted. So in general, this daemon set will be used to set up ELK. So in the coming classes, we are going to understand what is ELK. It is used for log aggregation, Logstash, Elasticsearch, Kibana. ELK stands for Elasticsearch, Kibana, Logstash. E stands for Elasticsearch, L stands for Logstash, K stands for Kibana. We are going to discuss this ELK stack in the coming classes. When I am going to set up the ELK stack, I need to install the Logstash. In order to install the Logstash, I need to create a pod in each worker node. So to create a pod in each worker node, we will go for daemon set. Daemon set is Kubernetes resource to create the pods. Daemon set will create one pod in each worker node. When we add a node to the cluster, then pod will be created. If we remove node from the cluster, then pod will be deleted. What are the use cases to go for the daemon set? When to use a daemon set? Normal for application deployment, for a database deployment, we don't go for the daemon set. Daemon set is used for logs collector. Okay. The second one is node monitoring. So in my worker nodes, my pods will be running. When my pods are running on the worker node, I want to collect logs from the worker node. In the first worker node, my pod is available. In the second worker node also, my pod is available. I want to collect the logs from the first worker node, and I want to collect the logs from the second worker node. To collect the logs from the first worker node, one pod should be there on the first worker node. To collect the logs from the second worker node, one pod should be there on the second worker node. So I need to create a pod to collect the logs on each worker node. Which pod? Logstash pod I will create. Logstash is a software. I need to deploy Logstash pod in each worker node. To deploy this Logstash pod on each worker node, I need to deploy the Logstash as a daemon set. And as my worker nodes are running, as my application is running in the worker node, I need to monitor each worker node behavior. To monitor each worker node behavior, we are going to deploy the metric server on each worker node. To deploy that metric server also, we are going to use daemon set. Guys, you got the clarity? What is the daemon set now? You got the clarity what is daemon set in the Kubernetes? Daemon set is also one of the resources in the Kubernetes which is used to create the pods. Here you have options to create the pods in the Kubernetes. Manually we can create the pods. If you create the pods manually, Kubernetes will not manage our pod lifecycle. If you want Kubernetes to manage your pod lifecycle, then you need to go for replication controller, or replica set, or deployment, or stateful set, or daemon set. Now here, when you go for replication controller, you don't have a control in which node your pod will be created. It may create on the first worker node, or second worker node, or third worker node. You don't have any control on that. Then we will go for replica set. Replica set also, you don't have a control in which worker node the pods will be created. Same thing with the deployment also. Same thing with the stateful set also, right? But when you go for the daemon set, very confidently we can say that my pod will be created in every worker node available in the cluster. If you have 10 worker nodes, then each worker node will have one pod. So what are the general use cases to go for the daemon set? Daemon set is used for logs collector and node monitoring like this. Got it? So now the practicals of the daemon set I'm not going to do now. The practicals of the daemon set we will do with the ELK. So I'm not going to implement the daemon set pods now. So daemon set pods I will implement when I'm going to explain ELK. So just I want to give you the overview. What is the daemon set now? In the coming classes, we are going to do practicals on the daemon set. Now, are you able to understand, guys, what is a daemon set and why we need to go for daemon set? Guys, are you able to understand what is the daemon set and why we need to go for daemon set? Yeah. Can you guys tell me what is the daemon set and why we need to go for daemon set? Can you tell me what is the daemon set and why we need to go for daemon set? Daemon set is one of the resource in the Kubernetes. How we have deployment stateful set? How we have deployment stateful set? Use it to create worker nodes. Pradeep, it is not used to create the worker nodes. Your answer is wrong. It is used to create the pods in the each worker node. Daemon set will create one pod in each worker node. Deployment is available, stateful set is available, right? And daemon set is available. Daemon set is Kubernetes resource to create the pods. Daemon set will create one pod in each worker node. When we add node to cluster, then pod will be created. If we remove node from cluster, then pod will be deleted. So now, if you want to create pod in each worker node, then we will go for daemon set. So in the interview, if anybody asks you, what is daemon set, where you have used in the project, you can say that daemon set is one of the resources in the Kubernetes to create the pods. By using daemon set, we can create the copy of the pod in the each worker node. In our project, we have ELK setup. So to set up this ELK, we have used daemon set. You can say that. So we can say that we are using daemon set to set up ELK in our cluster. So when you go for ELK, Elasticsearch, Logstash, Kibana, 3 components will be available. We have a separate session on the ELK. And we are going to understand at that time how to work with the daemon set practically. So now I covered just a theoretical point. What is daemon set and what is the purpose of it and when we will use the daemon set. Practicals we are going to discuss in the coming classes. All right. Fine, guys. So with this, we are able to understand Kubernetes resources. Now, we are using replication controller to create the pod. You can create the pod manually in the Kubernetes, but when you delete the pod will not be recreated. Kubernetes will not manage your pod lifecycle. So that's why we are going to use replication controller to create the pod, right? When you go for the replication controller, always it will maintain given number of pods count. Always will maintain the given number of pods count. If I say 2, always 2 pods will be available. If one pod is deleted, no problem, it will create another pod in place of that. So as a alternate for the replication controller, we got replica set. Replica set is also a Kubernetes resource which is used to manage pod lifecycle. Right. Next one, we are having deployment. When you go for replica set, the pod scaling is a manual process. In the deployment, we are having a auto scaling concept. Deployment is the most recommended approach to deploy stateless applications. Right. When you are having stateful applications, then we need to deploy the pods by using stateful set. Yesterday only we discussed deployment and stateful set difference. That is also damn sure interview question. Deployment is used to create the pods with the random name, and the scale down will delete the pods in the random order. So the pods are stateless when you go for the deployment. So when you want to deploy stateful containers, stateful pods, we need to go for stateful set. Stateful set will create the pods with a sticky identity, and first primary pod will be created, then the secondary pods will be created. Scale down will delete the pods in the reverse order when you go for stateful set. Apart from this, now in these 4 scenarios, guys, in these 4 resources, we don't have any control on which worker node our pod will be created. That will be taken care by control plane. But if you have a requirement to create the pod in each worker node, one pod should be created on the each worker node. Then we need to go for a concept called daemon set. So generally, to collect the logs from the nodes and to monitor the nodes performance, we are going to deploy our pods by using daemon set concept. So daemon set use cases, logs monitoring, logs collecting, and nodes monitoring. In the future, we are going to work on the ELK. In that ELK class, you will understand what is this daemon set, how to do the practicals on the daemon set. Are you guys clear with the Kubernetes resources that we are using to create the pods? In the Kubernetes, everything is pod only. In the Kubernetes, everything is pod only. So the pods we can create, we can scale up the pods, we can scale down the pods. So Kubernetes will manage our containers inside the pods, right? So these resources we will use to create the pods so that these resources will manage our pod lifecycle in the Kubernetes. If any pod is deleted, no problem. That pod will be recreated by Kubernetes. Are you clear? With the deployment, stateful set, daemon set. These are used to create our pods in the cluster. Yes, perfect. Next one, the next topic in the Kubernetes is Helm charts. The next topic in the Kubernetes, that is Helm charts. Okay, Helm charts. Helm, what is the Helm and what is the purpose of the Helm? Guys, in the Kubernetes, Helm is a package manager. Helm, what is a Helm in the Kubernetes? Helm is a package manager for Kubernetes applications. What is the meaning of a package manager? Simple example. Now here, guys, I'm having Amazon Linux machine. In the AWS, I'm creating Amazon Linux VM. Assume that. I have one machine. That machine is using Amazon Linux VM. Similarly, I am having another machine called Ubuntu machine. Ubuntu Linux VM. Both are Linux machines only, but different Linux flavors are available. Okay, Amazon Linux VM is available and Ubuntu Linux VM is available. When you go for Amazon Linux VM, if you want to install any software, then we will go for yum package manager. Yum is the command that we are going to use to install any software in the Amazon Linux VM. If you want to install any software in the Ubuntu Linux VM, we will use yapt package manager. Okay, guys. So if you are going for Amazon Linux VM, then to install any software in the Amazon Linux machine, we will go for yum package manager. If you going for Ubuntu Linux VM, to install any software, we will use apt package manager. In the Windows, suppose I want to download some software in my Windows machine. Then what we will do generally, we will go to Google and we will type our search operation, download Git client. Okay, I will click on this URL Git downloads and I will click on download button. So that here 32-bit or 64-bit, I want to get the 64-bit for my machine. So when I click on this link, if you see, the Git software is downloading with the .exe file. So this is Windows machine. We are having GUI. Using this GUI, we are able to click on the links and we are able to download the software. Then we will double click on this software and we are going to install that software. So this is the process. Now you see the Git is getting installed in my system. Click on install. So with this, Git client software will be installed in my Windows machine. So Windows is GUI based operating system. Whereas when you go for the Linux machine, let me connect it to my Linux machine, which is available in the AWS. In my Linux machine, that is CLI based. So there is no GUI in order to install the software. In the Windows, we are having GUI to install the software. Okay, so you have seen that I downloaded Git client and I'm installing the Git client in my machine. we can see how that software is getting installed also. But when it comes to Linux machines we are using as virtual machine, nothing but only we can see CLI, command line interface. We can't have the browser in that machine to download the software and install the software. So that's why in the Linux, we will be having a software called package manager. So in the Linux machines, if you want to install any software, then you need to use package manager. Now see here, I have my EC2 instance. We created EC2 instance to communicate with the cluster. That EC2 instance I created by using Ubuntu. Okay, copy this IP address, connect it to this machine by using MOBA Extra. Connected to this machine by using MOBA Extra. Right, session SSH, username is Ubuntu, SSH settings, private key, temp file, click on OK. Right, with this, I connected to that machine, guys. Once I connected to this machine, now I want to install one software in my machine. For example, Git I want to install. To install the Git in the Windows, what I have done? I have downloaded that software and I installed that software. Git is installed in my machine. Okay, but the Git software I want to install in my Linux machine. So here, do you have a browser to install? We don't have it. So that's why in the Linux, we will use a concept called package manager to install the software. If your Linux machine is based on Amazon Linux or Red Hat Linux, then you will go for yum package manager. If it is a Ubuntu Linux, then you will go for apt package manager. Now, if I want to install Git in my machine, then what I need to do? Sudo apt install Git. Now you see Git is installed. Reading that's removed 7 not upgraded. Git is already in the newest version. Git is available in my machine. For example, let us check Java version. So do we have Java in this machine? Yes, Java is available, already installed in this machine. Git is available, Maven. If I want to install the Maven, then I need to go for sudo apt install Maven. Right. So Maven software is installed in our machine. So how I am installing the software in this machine? By using apt package manager. Sudo, that means super user permission. Apt is a package manager. Install Git. So similarly, Maven we can install. Similarly, Java we can install. So here, based on the Linux machine, that package manager is going to be different. So if it is Amazon Linux, if I want to install Git client in the Amazon Linux, then the command that I'm going to use is sudo yum install Git. So yum is a package manager for Amazon Linux. Similarly, in the Ubuntu, if you want to install a software, sudo apt install Git. If you want to install Maven or Java in the Amazon Linux machine, the command that we will use is sudo yum install Java. So same Java, if you want to install in the Ubuntu Linux machine, instead of yum, we need to use apt. If you want to install Maven in the Amazon Linux machine, sudo yum install Maven. So same thing, if you want to do in the Ubuntu, that is apt install Maven. Sudo yum install Maven here, and here the same software can be installed by using apt. So every Linux machine will have a package manager. So in the Amazon Linux, if you observe, yum is a package manager. In the Ubuntu Linux, we are having apt as a package manager. Are you guys able to understand my point? What is yum package manager and what is apt package manager? Yum package manager, yum is a package manager to install a software in the Amazon Linux. Apt is a package manager to install the softwares in the Ubuntu Linux. Similarly, now my Kubernetes cluster is running. In the Kubernetes cluster, I want to install some softwares. As I told you, ELK is available. ELK I want to install in my cluster. And I want to install metric server in the cluster to monitor the performance of my cluster. So if you want to install any software in the Kubernetes cluster, then we will go for Helm charts. What is Helm? Helm is a package manager for Kubernetes cluster. Helm is a package manager for Kubernetes cluster. What is the meaning of a package manager for Kubernetes cluster? If you want to install any software in the Kubernetes cluster, then we can go for Helm software. By using Helm, we can install the softwares easily, right? So if you are having a Linux machine, in the Linux machine, how we are installing the softwares? In the Linux machine, we are installing the softwares by using package manager. Yum is a package manager for Amazon. apt is a package manager for Ubuntu, right? So similarly, if I want to install some software in my cluster, then we can go for Helm package manager. Are you guys clear? What is a Helm now? Are you clear what is a Helm in the Kubernetes? Helm is a package manager for Kubernetes applications. Helm allows you to install or deploy applications on the Kubernetes cluster in a manner to yum or apt for Linux distributions. How you are installing the softwares in the Linux machines by using yum and apt package manager? Similarly, we can install the softwares in the Kubernetes cluster by using Helm package manager. Helm manages Kubernetes resources packages through charts. Chart nothing but collection of YML files. Now, if I want to deploy my application, I'm writing one YML file. So multiple YML files we need to write in order to deploy our applications. Instead of we are writing those YML files, we can download Helm charts. What is the Helm? Helm is a package manager for the Kubernetes applications. What is the purpose of the Helm? Helm is used to install the required softwares in the Kubernetes cluster by using chart. What is a chart? Chart is a collection of files organized in the specific directory. The configuration information related to the chart is managed in the configuration. A running instance of the chart with specific config is called as a release. So for every software, one chart will be available. Now I want to install ELK, Elasticsearch, Logstash, Kibana, 3 products I want to install to monitor logs of my applications running in the cluster. So to install the ELK, you don't need to write the manifest YMLs. Simply, you can go for a Helm, and by using Helm, you can install that ELK. So if you want to install any software on the cluster, then we can go for Helm. And similarly, now I want to monitor my cluster performance, how my nodes are working, how much memory consumed by my nodes, how much memory consumed by my pods. I want to monitor my cluster. To monitor my cluster, I want to install metrics server. To monitor my cluster, I want to install metrics server. Instead of I'm installing the metrics server manually in the cluster, I can use Helm package manager. I can tell to Helm, hey Helm, install metrics server in our cluster. Then Helm will install the metrics server. I will tell to Helm, hey Helm, install ELK stack in our cluster to monitor logs of our worker nodes. Then Helm is going to download the ELK from the ELK chat and it is going to install that. So I hope you got the clarity. What is the Helm in the Kubernetes? Guys, what is the Helm in the Kubernetes? Come on. What is the Helm in the Kubernetes? Helm is a package manager for Kubernetes applications. What is the meaning of a package manager? What is the meaning of package manager? Can you tell me? What is the meaning of a package manager? Helm is a package manager for Kubernetes applications. Package manager means it is used to deploy or install the softwares on the Kubernetes cluster. So in the Linux, we are using package managers to install the softwares. apt package manager, yum package manager available for the Linux to download the softwares. Similarly, In the Kubernetes cluster, if you want to download the software, then we will go for Helm. Helm is a package manager for Kubernetes applications. Helm will allow you to install or deploy applications on the cluster. How you will do it in the Linux? In the same way you can do it on the Kubernetes. Helm will use a concept called chat. Chat nothing but collection of configuration files. Okay, good. Now let us see Helm architecture. Now here I am having Kubernetes cluster. In the Kubernetes cluster, API server will be available. We already know our cluster architecture. Control plane will be available. In the control plane, API server, etcd, scheduler, controller manager, and worker nodes will be available. In the worker node, kubelet, kubeproxy, pod, inside the pod, container will be available. Now here, when you want to install some software in the Kubernetes cluster, first we need to install Helm client software. We need to download and install Helm in our cluster. Once we install the Helm, by using that Helm, we can download the remaining softwares. So Helm will maintain a repository that is called chat repository. For every software, Helm will maintain one chat. For example, I want to install metric server. Metric server will have one chat. I want to install ELK. ELK chat will be available. And I want to install Grafana Prometheus to monitor my cluster. So Grafana Prometheus, Grafana will be available as a chat. Prometheus will be available as a chat. Right. In my cluster, I want to install metric server. I want to install Grafana. I want to install my Prometheus. I want to install ELK. For all these things, Helm chats will be available. Now, in my cluster, I want to install metric server to monitor my cluster performance. And I want to install Grafana to monitor the cluster with graphs. I want to install Prometheus to send the alerts from the cluster, right? Grafana, Prometheus, this ELK, metric server, all these softwares that we are using for monitoring purpose in our Kubernetes. In order to do such kind of monitoring, we need to install those softwares in the cluster. In order to install those softwares in the cluster, we are going for Helm chat. Helm chat repository will be available. First, we'll install the Helm client in our cluster. Once we install the Helm client, then chat repository will be available. Helm chats. Chat nothing but set of configuration files to install that software. Okay. Now let me go and install Helm in our cluster. We understand theoretically what is a Helm. Helm is a package manager which is used to install required softwares in our cluster. Okay, let me go here. Let me check the Helm nodes. Right. Yeah, right guys. So here I'm having Helm installation document. Helm installation is available. So now let me take this command and install the Helm. Before going to do that Helm installation, let us check Helm is available or not. Command Helm not found, but can be installed with sudo snap install Helm. Right. Here I'm going to use this curl command to download the Helm. I'm going to use this command to download the Helm. Now execute this. Yes, once it is done, then let us give the permission to execute that. I'm giving the permission. Then once it is done, install that shell script file of the Helm. When you see ls-l, you can see the Helm is downloaded. Get helm.sh. There is a shell script file available. Now I need to execute that shell script file. So how we are going to execute that shell script file? /get helm.sh. That shell script file I'm executing. So with this, Helm is getting downloaded and Helm is installed in our cluster. So once a Helm is installed in our cluster, let us verify the Helm. Sorry, HELM. Helm. Now Helm is installed. We are able to see all the Helm packages also. Good. Fine. So with these three commands, we are able to install the Helm. Now here guys, check do we have metric server on the cluster. I want to see the pods running in the cluster and which pod is taking how much memory, how much resources. Now When I execute a command called kubectl top pods, it is saying that metrics API not available. So now, similarly, I'm going for kubectl top nodes. So there are two worker nodes available. Which worker node is taking more memory? How much memory is taken by each worker node? I want to monitor. So for that, there is a command called kubectl top pods command. Kubectl top nodes command is available. Now, am I able to execute top pods command and top nodes command? I'm not able to execute. Here, it is saying clearly, when I execute kubectl top pods, metrics API not available. When I execute kubectl top nodes, it is saying that metrics API not available. Now I want to install metrics API. So instead of downloading and installing the metrics API manually, I will install the metric API by using Helm. Already Helm is installed in my machine. Now, in order to install the metric server, first let us add the metric server to our Helm repository. So before you can install the chat, you need to add the metric server repo to the Helm. Now, let me go for Helm repo. Let me go for Helm repo, add metric server. So metric server has been added to your repository. Once the metric server is added to our repository, let me upgrade that. Let me install that metric server. So it is saying that metric server does not exist, installing now. By using Helm, I'm installing the metric server. Once we have installed the metric server, now let us go and execute. Let us go and execute kubectl top pods command. Kubectl top pods command. So service unavailable. The server is currently unable to handle the request. Get pods metrics kubernetes.io. So it may take some time. Kubectl top pods, kubectl top nodes. Now you see earlier when I execute the top nodes command, it was saying that the metrics API not available. Now when I execute kubectl top nodes, I'm able to get the two worker nodes details are available. CPU cores, CPU utilization. So here first worker node having 15% utilization. Second worker node is having only 2% utilization. Memory and memory percentage is also. We are able to get the information about our worker nodes. How much memory they are using and how much percentage of the CPU is utilized in our worker nodes. We are able to monitor that by using kubectl top nodes command. When I execute kubectl top nodes, first time it was saying that metrics API not available. Now I have installed metrics API by using Helm. First I installed the Helm software. By using the Helm software, I installed the metric server. By using this metric server, I'm able to get the top nodes details as well as the top pods details. Kubectl top nodes, kubectl top pods. Now you see in my cluster, these are the pods running. So how much memory that pods are occupying, we are able to get that. So metric server is available and our DB deployment. Yesterday we have deployed our database by using stateful set. As we deployed with the stateful set, we can see sticky identity for the each pod. We can see sticky identity for the each pod. Are you guys clear? Right. So with this, we are able to install. Metric server in our system. Whenever you install the metric server, if you are facing any issue, then I have given you a fix also for that issue. Sometimes the metric server may not be installed. When it is not installing, we need to edit the deployment of that, and we need to, this is the existing file, and in that file, we need to add these properties. We need to add these two properties, then the metric server will work. After the metric server got installed, we are going for kubectl top pods and kubectl top nodes. So what is the meaning of kubectl top pods? Kubectl top pods, they are used. Kubectl top pods, they are used to, that command is used to get the pods information and how much memory occupied by our pods. And kubectl top nodes is available. Top nodes command is used to get the information about the worker nodes which are running in the cluster. Got it? What is a Helm? Helm is a package manager for the Kubernetes applications. Helm will allow you to install or deploy applications on the cluster in the manner how you will do the software's installation in the Linux. Helm manages Kubernetes resource packages through charts. What is a chart? Chart is a collection of files organized in the directory to install the software. Now I am installing metric server. Metric server having a chart. Within the chart, the configuration YMLs will be available. Instead of we are writing those YMLs, the chart we are going to install. Right, fine. So here our Kubernetes cluster is available. In our Kubernetes cluster, Helm software we have installed. Okay, by using this Helm, we can install the remaining softwares. How Helm will install the remaining softwares? Helm will install the remaining softwares from the chat repository. That means Helm will maintain all the charts in a repository. Suppose for metric server, one chart will be available. For Kibana, one chart will be available. For Grafana, one chart will be available. For Prometheus, one chart will be available. Like this, for every software that you want to install, that Helm will maintain a chart in the chat repository. When you install the chart, then Helm will download the chart configuration files from the repository and will install the software in our cluster. So here I have installed metric server. How I have installed the metric server? So to install the metric server, first I have installed the Helm. Helm is installed. After Helm is installed, I executed top pods. That command did not work for me. Top nodes also did not work for me. Then after I have added metric server to the Helm repository. Then I have installed that metric server by using Helm. Then after we can check the top pods and top nodes. The commands which did not work earlier, now you can check those commands once your chart is installed. Once your chart is installed, then you can execute kubectl top pods, kubectl top nodes. For example, if you want to delete that metric server, Helm delete release name. So whatever the metric server you installed on the cluster, that metric server you can delete by using Helm delete command. Good. So we understood what is Helm, right? Now we are going to install the remaining softwares also Helm, and we will practice the Helm. Good. Next one, guys. In the Kubernetes, we are going to install some monitoring softwares. One is Prometheus, another one is Grafana, and the third one is ELK stack. So three things are available here. So let us understand what are those three things. Helm is a package manager for Kubernetes cluster. Now here, Helm installation I am giving. Metric server availability fix. If you are facing any issue with the metric server, then you can resolve that issue with the option that I have given. I'm not facing that issue now. Helm installation. Helm is a package manager for Kubernetes cluster. Helm is used to install required softwares in Kubernetes cluster. Helm is used to install required softwares in Kubernetes cluster. Helm will maintain charts. Helm will maintain charts in chart repository. Helm will maintain charts in chart repository. Chart means collection of configuration files. Chart means collection of configuration files organized in a directory. Instead of we are writing manual YML files to deploy the softwares in the cluster, we can go for Helm chart. This is our Helm installation process. Once the Helm is installed, you can install the metric server. Once the metric server is installed, you can monitor your nodes and you can monitor your pods by using top pods command, top nodes command. So first, without installing the metric server, we are executing these commands. These commands will not work. After installing the metric server, we are executing those commands. Then those commands will work. Now those commands are working. In there, when I execute kubectl top pods, it is saying they're currently unavailable. But now when I execute top pods, I'm getting the response. When I execute top nodes, I'm getting the response. Now you see here. Why we are getting the response now? Metric server is installed. kubectl top pods. So what are the pods running and how much memory using by pods? So if you install metric server in the cluster, then only you can see this output with this command. If a metric server is not available, you will not get that output. How I install metric server? By using Helm chart. Now similarly, Let us go for kubectl top nodes. kubectl top nodes. When I go for kubectl top nodes, it is saying that what are the nodes available, how much is CPU utilized, how much memory, and memory percentage. So that top nodes information and the top pods information we are able to get with the metrics server. Right. Now, similarly, now guys, in the Kubernetes, we are going to use some monitoring tools. We are going to use some monitoring tools in the Kubernetes. Kubernetes monitoring. In the interview also, they will ask how you will monitor your applications which are running in the Kubernetes. In the Kubernetes, to monitor, we are going to use softwares like Grafana, Prometheus. Grafana and Prometheus, these are the softwares that we are using for monitoring. These are for, this is GUI based monitoring. Okay, this is alerting software, alerts. And we are having ELK or EFK. ELK or EFK, that is used for logs monitoring. That is used for application logs monitoring. So in the Kubernetes, we are having several monitoring softwares. So first one is Grafana, second one is Prometheus. Grafana and Prometheus are used for our cluster monitoring, whereas ELK and EFK, they are used for application logs monitoring. Okay guys, now if you go to here this PPT, you can see that what is Grafana, what is Prometheus. Helm we understood. Helm is a package manager that is used for Kubernetes applications. It is used to install the softwares. Helm architecture, we install the Helm. By using Helm, we install the metric server. Then what is Prometheus? Prometheus is an open source system monitoring and alerting toolkit. So my application is running in the Kubernetes cluster and I want to monitor my application and I want to monitor my cluster. My application running successfully or not? Memory, sufficient memory is available in the worker nodes or not? Is there any problem available in the worker node? I want to monitor that. In order to do that monitoring, we will go for Prometheus. Prometheus is an open source systems monitoring and alerting toolkit. Prometheus collects and stores its metrics as a time series data. When my application is running, metrics will be generated. The metrics will be collected by this Prometheus software. Prometheus is an open source systems monitoring and alerting toolkit. Prometheus is an open source software. Prometheus collects and stores its metrics as a time series data. It provides out-of-the-box monitoring capabilities for the Kubernetes container orchestration platform. When you are using Kubernetes as your orchestration platform to run your applications, you should be able to monitor your application. You should be able to monitor your cluster also. In order to do that, we are going for Prometheus. Prometheus is an open source systems monitoring and alerting toolkit. Then what is Grafana? Grafana is also analysis and monitoring software. Grafana is also used for monitoring analysis. So already Prometheus is available, then why we need to go for Grafana? With the combination of Prometheus and Grafana, we are going to monitor our cluster. Grafana is an analysis and monitoring tool that is also open source software. The thing is, Prometheus will give you the analysis metrics graphically. In the web application, it will provide the graphs and alerts, right? It will connect it to a supported data source. Now, if you see here, Grafana will connect with the Prometheus for the data. Prometheus will monitor our cluster, will monitor the application which is running in the cluster. Prometheus will collect the data from the cluster. Prometheus will give the data to the Grafana. Grafana will provide the data in the graphical format like this. Okay. If you see the architecture, we are going to install Prometheus, and Prometheus server will connect with our Kubernetes cluster. Prometheus will collect the data from our nodes, from our pods, and Prometheus will give that data to the Grafana. Grafana will provide the data visualization concept. Data visualization concept will be available when we go for this Prometheus and Grafana. ELK, that is a different story. ELK is used for log monitoring. For the cluster monitoring, we are going to use Prometheus and Grafana. Prometheus and Grafana both are open source softwares only. Both are used to monitor the Kubernetes cluster and the applications which are running in the Kubernetes cluster. So now here, I want to install Prometheus. I want to install Prometheus. I want to install Prometheus. I want to install the Prometheus. Prometheus is going to monitor the cluster, and Prometheus will collect the data from the cluster, and Prometheus will give the data to Grafana. Then what the Grafana will do? Grafana is going to present the data in the form of graphs. Now, if you see the architecture, in our cluster, we will install the Prometheus and Grafana. Prometheus will collect the data from the cluster. Prometheus will give the data to the Grafana. Grafana will provide the data in the graphical format with the dashboard, with the graphs and alerts and all the things we can monitor by using this Grafana. So Grafana and Prometheus are called as monitoring softwares for our Kubernetes cluster. Grafana and Prometheus are called as monitoring softwares for our Kubernetes cluster. ELK is also monitoring software, but ELK monitoring is used for application logs monitoring. To monitor the application logs, we are going to use ELK or EFK. Grafana and Prometheus are used for Kubernetes cluster monitoring. Now I want to install Prometheus and Grafana in my cluster. Instead of installing this Grafana Prometheus manually, we can go for Helm charts. We can go for Helm charts. Are you clear? Now I want to install Grafana and Prometheus in my cluster. In order to do that installation, we can go for Helm charts. In order to do that installation, we can go for Helm charts. Are you guys clear with my point? Right. Kubernetes monitoring. We can monitor our Kubernetes cluster and cluster components using below softwares. One is Prometheus and the second one is Grafana. To monitor our Kubernetes cluster and cluster components, we are going to use below softwares, Prometheus and Grafana. What is Prometheus? Prometheus is an open source system monitoring and alerting toolkit. Prometheus collects and stores its metrics as time series data. Continuously, Prometheus will collect the data from the cluster and it providing out of the box monitoring capability for the cluster. Right. Then what is Grafana? Grafana is an analysis and monitoring tool. Grafana is a multi-platform open source software. It provides charts, graphs, and alerts. Now here, Grafana will connect with the Prometheus for data source. Grafana will connect with the Prometheus for the data source. That means Prometheus will monitor the cluster. Prometheus will get the data. Prometheus will give the data to Grafana. Then Grafana will provide the web application for you to monitor your cluster and the cluster data. How to deploy Grafana and Prometheus in the Kubernetes? Using Helm charts, we can easily deploy Prometheus and Grafana. Okay, install Prometheus and Grafana in the Kubernetes cluster by using Helm charts. Right, already we installed Helm. First, let me add Helm stable repository. Go here, Helm repository, add stable. Stable repository, I'm adding. Stable has been already added. Add the Prometheus repository to the Helm. So this is Prometheus community. I'm trying to download the Helm chart for that. Adding that Prometheus community to this Helm has been added. Prometheus community has been added to our Helm repository. Once I have added that, let me update that repository. Helm repo updated. Yes, that is successfully updated. Update completed. Happy Helming. It is just for using for searching purpose. It is not required. Install the Prometheus. Now I have added the stable repository. I have added a Prometheus community to the repository. Then I want to install Prometheus here by using Helm. Helm install stable Prometheus community. Before going to do that, kubectl get pods. Let us check the pods. Now, only my metric server pod is available and my database pod is available. Okay, now let me install this Prometheus stack. Let me install the Prometheus stack. Helm install stable Prometheus community. By using Helm, I'm trying to install the Prometheus stack. Prometheus stack will install Prometheus as well as Grafana. Prometheus and Grafana are called as Kubernetes monitoring softwares. It's taking time. Yeah. So once that is installed, then we can change the Prometheus pods and we can change the service type and we can access Grafana dashboard and we can see that. Yeah. Now you can see Helm install stable Prometheus community. The Prometheus and Grafana got deployed. So I'm not writing any manifest YMLs to deploy the Prometheus pods and Grafana pods. I'm using Helm chart. Once it is installed, you can see the status is deployed. Namespace, in the default namespace only, they deployed. Now, let us go here. kubectl get pods. Wow, so many pods are deployed. Alert manager pod is deployed just 48 seconds ago. Alert manager, Prometheus stable pod deployed, stable Grafana pod deployed, Kube Prometheus, Kube state metrics, Prometheus node exporter, Prometheus node exporter. See, all these pods are deployed in our cluster. In general, in order to deploy the pod, we need to create a manifest file. But to install these softwares, am I creating any manifest files or I'm using Helm charts? Am I creating any manifest files or I'm using Helm charts for doing this? I'm using Helm chart for accessing this. I'm using Helm in order to install Prometheus and Grafana. So with this, what we have installed in our cluster. With this, can I say Prometheus and Grafana is ready in the cluster? With this, can I say Prometheus and Grafana is ready in the cluster? Guys, come on. With this, our Prometheus and Grafana is ready in our cluster. What is the purpose of Prometheus and Grafana? Guys, whatever is there in the PPT, same thing I kept here. What is the Prometheus? Alerting software. What is Grafana? Visually, we can monitor our cluster metrics. So I have deployed the Prometheus and Grafana by using Helm. Now, I'm executing a command called kubectl get pods. When I execute kubectl get pods command, it is displaying what all the pods that are deployed in the Kubernetes cluster. Now, kubectl get service. Can you check the service now? Oh my God. See how many services are created. How many services are created? Alert manager service is headless service. And here metric server service is available. Prometheus operated is available. Spring Boot MySQL service is available as a node port service. And stable Grafana service is available. Kube Prometheus, Kube state metrics, Prometheus node exporter. And my database service is available. My database service is a headless service. And this my Spring Boot application service is the node port. Remaining all are cluster IP services. Now my Prometheus and Grafana running in the cluster as cluster IP. Can I access these things outside the cluster? Can I access these things outside the cluster? Can I access my Grafana and Prometheus outside the cluster? Prometheus and Grafana pods are running. Those pods are exposed by using service. What is the service type they are using by default? They are using the service type as a cluster IP. They are using the service type as a cluster IP. Now, I want to access this Grafana outside the cluster and I want to monitor my dashboard. I want to access this Grafana Prometheus outside the cluster and I want to monitor. So in order to access them outside, we need to change the service type. So how many services are there in the Kubernetes total and what is the purpose of those services? Can you guys tell me How many services are there in the Kubernetes and what is the purpose of those services? Come on, guys. How many services are there in the Kubernetes and what is the purpose of those services? Total 3 services are available in the Kubernetes. What are those 3 services? What are those 3 services? One is cluster IP, second one is node port, and third one is load balancer. Cluster IP means we can access only within the cluster. Node port means we can access outside by using node IP. Load balancer means load will be distributed. One load balancer will be created in the AWS. Using the load balancer URL, we can access them. Now, my Grafana pods are running. My Prometheus pods also running. They are exposed as a cluster IP service. Can I access them outside or I cannot access them outside? Can I access them outside or I cannot access them outside? I cannot access them outside. In order to access them outside, then what I need to do? In order to access them outside, then what I need to do? I need to change the service type. Okay, here I have given the commands for that. So after installing that, whenever you execute the get pods, you should see Prometheus pods running. Check the services. By default, Prometheus and Grafana services are available within the cluster as a cluster IP. To access them outside, let's change it to node port or load balancer. By default, my Grafana pods and Prometheus pods are running with the cluster IP. So I can access them only within the cluster. If I want to access them outside, then I need to change the service type to node port or load balancer. Are you clear? How can we change them? Here, do we have our manifest files to change them or we are using Helm chat to install them? Guys, do we have our manifest files to change the service type or we are installing by using Helm now? Do we have our manifest files or we install them by using Helm? We installed them by using Helm. Now directly we can change the service by using kubectl edit service name. This is the service name. Now I will change that. Edit the service and change it to load balancer. Change it to load balancer. Then save and close that file. Okay, let me edit this file. Before going to do that, if you observe in my Kubernetes, what are the load balancers are available? In my Kubernetes, currently you check any load balancer available. In my AWS account, currently any load balancer is available or load balancer is not available. Currently in my account, load balancer is not available. You got it? Now let me change the service type. I want to change Prometheus service to load balancer so that I can access that outside. This is the command. So service is already created. Now I want to edit that service. Click on edit that service. This is the manifest YML. Instead of we are writing this manifest YML, Helm chat providing the manifest YML. Kind is a service. Come down, service type. Service type. What is the service type available here? Cluster IP is the service type. Change the service type from the cluster IP to load balancer. What is the port number? 9090 it is using. Now I change it the service type to load balancer. Now save this. Yes, service got modified. kubectl get service. When I change it, now you can check it. The service type is modified to load balancer. Now see here. kubectl get service. The service type. Prometheus service type is change it to load balancer. This is the load balancer URL to access the Prometheus server. To access the Prometheus server. Refresh here. Now you can see one load balancer got created. Now you can see one load balancer got created. This is Prometheus server load balancer. Similarly, edit the Grafana server also. Change it to load balancer. Now edit the Grafana service and change the service type to load balancer. Then save and close that file. kubectl edit service stable Grafana. edit Grafana. Grafana service type will be available as cluster IP. Go here, edit this. These are the manifest files we are getting from Helm. Helm chats are available. Chat nothing but collection of manifest files. Now I'm changing that to load balancer. Grafana service type also changing to load balancer. Grafana also modified. Now kubectl get service. Now you can see kube stable here, stable Grafana service type change it to load balancer, and Prometheus service also change it to load balancer. Now with this URL, we should be able to access our Prometheus dashboard. This is load balancer URL. Still the site cannot be reached, or else what is the port number? Load balancer colon 9090. 9090. That is for Prometheus, and we are having Grafana also. Load balancer, and here we are having Grafana. This is Prometheus and this is Grafana. 30983 is the port number it is getting. This is my load balancer. Hit that load balancer URL. Let me enable that port. Security group, load balancer. What is the security group is available? This is the security group. Port number, edit the inbound roles. What is the port number it is using here? 30983. I'm trying to access the load balancer URL to access the pods which are running in the cluster. Grafana is running on 305419090. Yeah. Now you can see, guys, with the 9090, I'm able to access my Prometheus URL. So now Grafana should be accessible. Grafana is not up. Yes, perfect. I got the Grafana also. You don't need to enable the port number as well. Whatever the load balancer that created, you just to take this load balancer URL. For Grafana, direct URL you can access. So Grafana will run on the port number 80, by default 80. Now I'm able to log in into my Grafana. Similarly, for the Prometheus, you copy this URL. Prometheus port number is 9090. So you just go here, type colon 9090. So with this, I'm able to access my Prometheus and I'm able to access my Grafana. This Prometheus and Grafana pods are running in our cluster. Pods are running in our cluster. Okay. Now access the Prometheus server using load balancer URL. Using load balancer URL. Similarly, access Grafana server using load balancer URL. So whenever you execute get service command, you can see the load balancer URLs. Access Prometheus server using load balancer URL. Access Grafana server using load balancer URL. Load balancer URL. Now, how can we take the load balancer URL? So here we are going to take the load balancer URL. Whenever we execute a kubectl get service, it is giving Grafana load balancer URL. You just copy this URL and paste in the browser. When you go for a Prometheus, you just copy this URL with the port number 9090 with the load balancer URL. Prometheus URL, you need to type URL:9090. That's it. HTTP:/URL /load balancer URL:9090. So Prometheus server will run on the port number 9090. We need to specify that. When it comes to the Grafana, 80 is the port number. By default 80 will go. You don't need to specify. Just you need to specify load balancer URL for Grafana. For Prometheus, load balancer URL. From where you can copy the load balancer URL? From here you can copy the load balancer URL. And this is the port number, you can see clearly 80. When the port number is 80 for the Grafana, you no need to enable anything, just to copy this URL and access that. And when you go for a Prometheus service also running as load balancer URL is available. Prometheus having the port number as 9090. You need to enable 9090 port number. Okay. Once we are able to access our Grafana and Prometheus, now how to log in into Grafana? To log in into the Grafana, these are the credentials. Username for the Grafana is admin. Password for the Grafana is prom operator. So prom operator is the password. Username is admin. Click on login. So with this, we logged in into our Grafana server. So Grafana. So Grafana, here you can go here. You can search for the dashboards, general dashboard. Now, do you want to monitor your Kubernetes API server? Do you want to monitor alert manager? Do you want to monitor your cluster? You can click on the dashboard. When you click on the dashboard, it is going to give you the details about your cluster. It is going to provide you the details about your cluster. Okay. So here you can check the dashboard what you want. So recent dashboard and general dashboard. For example, you want to monitor your Kubernetes API server. So if you click on the Kubernetes API server, 100% it is available. Errors are not there in that. And so read availability available, write availability is available. How many requests we sent to the API server and how API server managed, how many config maps we created, daemon sets, deployments, endpoints, namespaces, nodes, volumes, pods, services. So what happened in our cluster, everything we can monitor. Everything we can monitor by using this Grafana dashboard. Okay, how much memory is consumed, how much memory is available, what is the CPU usage in our cluster, what is the CPU usage in our cluster. Everything can be monitored by using this Grafana dashboard. So here you can see what is your data set. Data set is the Prometheus. Who is giving the data for the Grafana? Data will be given by Prometheus. You can monitor last 1 hour data, last 30 minutes data, last 3 hours data, last 60 minutes data. Like this you are having last 2 days data I want to monitor. So like this you can check the cluster performance and cluster metrics by using this Grafana dashboard. So in the real time, we are going to use this Grafana and Prometheus. So once we log in into Grafana, then we can monitor our Kubernetes cluster. Grafana will provide all the data in the chat format. Now you can see here you can go to Grafana. You can select what do you want to monitor. What do you want to monitor in your cluster? So do you want to monitor your scheduler? Do you want to monitor your node exporter? Do you want to monitor etcd? So etcd currently nothing is available in the etcd, right? So all the Kubernetes components can be monitored from this Grafana. Kubelet. So go to Kubelet, Discord. Now, if you go for the Kubelet, running kubelets 2. Why two kubelets available? In every worker node, 1 kubelet will be available. Kubelet is called as node agent. How many pods are running in our cluster now? 17 pods are running in our cluster. How many containers are there? 27 containers are there. 66 actual volume counts are available. Like this, we can monitor our kubelet. Now, this is the pod start rate, pod start duration, in which worker node, which pod is started. So from how much time the pods are running, all this information, the pod statistics we can understand from this Grafana. See, the lot of beautiful graphs are displaying. Now I am monitoring the kubelet. So in the kubelet, if I select the dashboard in the kubelet, then it is saying that there are 2 kubelets are available. In those 2 kubelets, those 2 kubelets are running in the 2 worker nodes. In the 2 worker nodes, total 17 pods are running. In the 17 pods, total 27 containers are running. So like this, you can monitor our cluster by using this Grafana. How this Grafana is getting the data? Grafana is getting the data from the Prometheus. Already we have installed Prometheus also. Now Prometheus is used to monitor the cluster and give the cluster data to the Grafana. Grafana is providing that data in the graph format like this. Got it? So whatever the dashboard you want to monitor, you can monitor the dashboard. Here you can select. Do you want to monitor API server or do you want to monitor the cluster? So if you want to monitor the cluster, CPU utilization 2.49%, CPU request commit 22%, CPU limit commitment 10%, memory utilization 37%, memory request, memory limits communication, CPU usage is there, Cube system, the default namespace it is using, right? In the Cube system, there are 6 default pods are available. Those are the pods that are used for a cluster, right? 6 pods are there in the Cube system, 11 pods are there in the default namespace. In which namespace, how many pods are running, that also we can monitor from here. Cube system contains 6 pods. Cube system is a default namespace that will be used by our cluster to run the cluster components. Default is our namespace. In our namespace, 11 pods are running. Okay. So CPU requests, CPU limits, memory usage, network usage, network bandwidth. So everything we can monitor from this Grafana. Right? Now, Grafana overview, compute resource, nodes, node pods, Kubernetes node pods, discard this. Now, CPU usage of this. Now see what are the pods running. vShopify app DB deployment stateful set pod is available. CPU usage and Prometheus pods are available. Grafana pods are available. So those pods status, pods CPU limits, CPU requests, CPU usage, we can monitor. So these are monitoring. Now, vShopify app DB deployment, my stateful set pod is available. 373 MB memory it is using. So the remaining are Prometheus and Grafana pods are running and my DB deployment pod is also running. So like this, we can monitor everything related to our cluster. Node exporter, nodes, CPU utilization. So here nodes are available. How many worker nodes are there? 2 worker nodes are available. If I select 197, that is second worker node. 198, my first worker node. You see what is the average CPU percentage on the first worker node and on the second worker. So the graph is different. Memory usage 35.5%. When I go for this, when I go for first one, it is 39%. So the memory usage on the each worker node, we are able to monitor from this Grafana. So you see how many instances are available. Those instances are coming in the drop down. If you have 5 worker nodes, 5 IP addresses will be available. My worker node, nothing but a Linux machine, EC2 instance only. So when I select the first instance, it is saying that 39% memory used in that instance. When I select the second IP address, you can see this IP address clearly here. If you go to EC2 dashboard, instances running, one is my client VM, remove that. This is my another VM, 192, 168, 46, 198. Go to Grafana, 192, 168, 46, 198. Right? So that is using 35% of memory. So then go for second worker node. This is my second one, 192, 168, 18, 197. Now 18, 197. That is that. That worker node is using 40% of memory. So memory earlier it was 39, now it increased to 40. So you can monitor your nodes, your pods, your cluster, your namespaces, your containers, everything by using Grafana. Right? 9100 is the default port that cluster nodes will use for communication. 9100 is the port number they use it to communicate with the cluster. Cluster communication will happen internally with the port number 9100. Guys, are you clear? What is Helm? What is Prometheus? And what is Grafana? What is Helm? what is Prometheus, what is Grafana. You got the clarity? Helm is a package manager. Helm is a package manager. Helm is used to install required softwares. Helm is used to install required softwares in the Kubernetes cluster. Instead of we are writing the manifest files to install the softwares manually, we can go for Helm. Helm is a package manager that is used to install required softwares in the cluster. Okay. Now, daemon set, theoretically we understood. Practicals we need to discuss. Next topic is ELK stack only. In the ELK stack, we are going to understand the daemon set because I want to monitor the logs from my application. To monitor my application logs, I need to install ELK. ELK I will install by using daemon set. Helm chart. Helm is a package manager for the cluster. Helm is used to install the required softwares in the cluster. Helm will maintain the charts in the chart repository. By using Helm, I installed metric server and I'm able to monitor my pods and nodes. Then after that, I want to monitor my cluster. For that, I'm using Prometheus and Grafana. Prometheus and Grafana both are open source softwares. I deployed the Prometheus and Grafana by using Helm chart. After deploying that, then I want to monitor my cluster. So by default, Prometheus service and Grafana service will come as cluster IP. By using this edit command, I'm able to change them to load balancer. When you change them to load balancer, when you execute the SVC command, you can see the load balancer URL. You can access Prometheus URL and Grafana URL. To log in into the Grafana, you can go for admin and you can go for prom operator. Once we log in into Grafana, then we can monitor the cluster. Grafana will provide all the data in the graphs format or graphs or charts format. So whatever we are seeing that this is coming in the chart format or in the graph format. Here you can go to search dashboard. In the search dashboard in the general, you can see which dashboard you want to see. Alert manager or DNS, Grafana, API server, cluster, namespaces, pods, workloads, nodes, pod, controller manager, kubelet, cluster, namespaces, right? What do you want to monitor? Do you want to monitor scheduler? Do you want to monitor nodes? Do you want to monitor Prometheus? Everything that you can monitor here. Kubelet, API server, kubeproxy. So now when I go for the Prometheus statistics, Prometheus is telling that kubelet is there, API server is there, kubeproxy available, node exporter, this is Prometheus Grafana. When they have started, my kubelet started 1.5 weeks ago. Last week we created the cluster. From that time, my kubelet is running. I did not stop it. API server also running from that. 2 kubelets are available. In one worker node, 1 kubelet. In the another worker node, 1 kubelet available. API server is available. Kubeproxy available. Node exporter is available. Prometheus we deployed today. That is 26 minutes ago. 26 minutes ago we have deployed Prometheus. So all these information we are getting in the Grafana. How Grafana getting this data? Grafana is connected to Prometheus data source. Prometheus is getting the data from the cluster. Prometheus giving the data to the Grafana. Grafana providing the data in the graph format. Clear? Now the credentials these are the default credentials, guys. You don't need to set any credentials here. These are the default credentials when you are accessing the Grafana. The default username will be admin. The default password will be prom operator. You don't need to set anything. So you just access the URL, login page will open. You enter this username, you enter this password. Then you will log in into Grafana dashboard. Once you log in into the Grafana dashboard, go to search. Here in the general section, here you have all the dashboards that you can monitor. Alerting tools are available. Alert rules also we can configure. Alerting rules available. We can configure the alert rule. What is the alert rule? Grafana managed alert I want to configure. So you can configure your alerts also. When CPU utilization is more than 50%, I want to send a alert. Right? When CPU utilization is more than 50%, I want to make a alert. So Prometheus default alert. Now I want to apply some timing, right? Then I want to set the alert. Alert evaluation behavior. evaluate query, details for your alert, what is your rule name, summary, annotation, now run book URL, what you want to run when the alert is triggered. You can configure your alert as well. Okay. So meanwhile, go to this Helm, install the metrics, install the Prometheus, install the Grafana, and log into Grafana and monitor Grafana dashboards. Okay, guys. Tomorrow Sunday, we will discuss what is ELK and how to set up ELK in our Kubernetes to monitor logs of our application. Got it? So in the notes, everything is already updated now. So what is the Helm? How to install the Helm? How to install the metric server? What is Grafana? What is Prometheus? I will upload this notes file, and please set up Grafana Prometheus by using Helm chart. Tomorrow we'll discuss ELK stack in our cluster to monitor logs of the application. Thank you guys. With this, I'm stopping, and tomorrow we'll continue. Okay. Tomorrow, same timing class, and we will discuss the Helm chart with ELK. Good. Thank you guys. We'll upload the notes and video. We'll see you in the tomorrow's class.